So here we want to find the value of the expression 1 divided by the square root of 1 plus 1 divided by 999 squared plus 1 divided by 1000 squared minus 1. So clearly there's going to be some clever cancellation over here that we have to try to find. But for now, let's try to break this problem into some steps. Let's deal with the square root right here, because this is clearly the most difficult part in this whole expression right here. I don't see anything popping out that's very obvious. In other words, I don't really see a trick that we can use to simplify this. So let's just try to combine these three terms right here. It won't look pretty, but maybe there's some sort of cancellation there. So inside the square root, we have 1 plus this, right? The common denominator between these three terms is going to be 999 squared and 1000 squared. So for 1, well, that's just 999 squared times 1000 squared divided by 999 squared times 1000 squared. 1 divided by 999 squared just needs a 1000 squared term in the denominator. So when we add it, we get 1000 squared divided by, again, 999 squared and 1000 squared times 1000 squared. And for the 1 over 1000 squared, we get a 999 squared up here and a 999 squared times 1000 squared. And all of this is under these square roots. Now let's focus on the numerator of this whole expression. When we combine the terms, the numerator will be this, 999 squared times 1000 squared plus 1000 squared plus 999 squared. Now, as we can see over here, there are a bunch of these squared terms, but what's really interesting about this is that 1000 and 999 is just 1 away from each other, right? 1000 minus 999 equals 1. Maybe that plays into this question somehow, but how does it play into this question? Well, we see here we have a sum of squares. Some number squared plus another number squared. Let's write that as a squared plus b squared on the side margin here. So we have a term a squared plus b squared over here. Now, if it was a squared plus b squared plus a 2 times a times b, then we could easily factor that into a plus b whole squared. However, we can't do that because we don't have a 2 times a times b term in this numerator right here. It would be very convenient though if this would equal sum a minus b squared. Because if a was 1000 and b was 999, a minus b would just be equal to 1. 1 squared is 1. However, this is clearly not true, because a minus b whole squared goes out to be a squared minus 2ab plus b squared. So it's not equal to a squared plus b squared because there's this minus 2ab right here. However, if you add a plus 2ab, then this plus 2ab and this minus 2ab cancel out and you're left with a squared plus b squared. So if we do that up here, plus 2ab, then this is true. A squared plus b squared equals a minus b whole squared plus 2 times a times b. Now how does that help us over here? Well, if we set a to be equal to 1000 and b to be equal to 999, we're saying that 1000 squared plus 999 squared is equal to 1000 minus 999 squared plus 2 times 1000 times 999. 1000 minus 999, which is 1, or 1 squared, plus 2 times 1000 plus 999. Therefore, we can write the numerator as 999 squared times 1000 squared, same as here, but instead of this, we have 2 times 1000 times 999 plus 1. And this can be factored because, as we can see over here, if we set our a term to be 999 times 1000 and our b term to just be equal to 1, then this squared, the sum of those two terms, is equal to our numerator right here, because a plus b whole squared is equal to a squared, this term, plus 2 times a times b. In this case, b we can't see, but b is just the 1, plus b squared. And so that means we can replace this right here, all these terms in the numerator, with just this right here. So let's rewrite that. So now we have this inside of our square root, and we can see that both the numerator and the denominator is some term squared, and we have to take the square root of this whole thing. So we can just get rid of this power of 2 on all the terms to get 999 times 1,000 plus 1, all divided by 999 times 1,000. So we've managed to take out the dense square root in this term and replace it with this. Let's rewrite this whole term again. So now we have 1 divided by this term, which we just found, minus 1, as we can see in the original expression right here. But the 1 was changed to this form right here so that it can combine with this fraction right here. There is a 999 times 1,000 in this part and a 999 times 1,000 in this part. So when you combine the two fractions, these terms go away. Now you're left with 1 divided by, just a 1 divided by 999 times 1,000. Now we have these two fractions over here, which looks pretty messy. When you have 1 divided by another fraction, it's basically that fraction turned upside down. So now we have 1 divided by 1 divided by 1,000 times 999, which equals 999 times 1,000. Again, the numerator was 1 and the denominator was 1,000 times 999, but then if it's 1 over that value, then to simplify it, you just switch the numerator and denominator to get this right here. And now we just take 1,000 and multiply it by 999 to get 999,000. 999,000 is the answer to this expression over here, and we are done.